Happy Pi Day. Right, let's get stuck into question 4. So solve for x between 0 and 2 pi. So x is measured in radians. The equation 3 tan squared x plus 2 sec squared x plus 10 sec x plus 8 equals 0. So the identities we're going to need here. So there is a relationship between tan and sec. So I'm actually just going to prove the identities. If we start with cos squared x plus sine squared x equals 1. You divide everything by cos squared x. So all three terms. So algebraically it's valid. Doing the same thing both sides. That means we get 1 plus tan squared x equals sec squared x. And this is the identity we're going to use. So from here we can actually say that tan squared x is equal to sec squared x subtract 1. We're going to put this all the way in here. So we're going to get 3 open bracket sec squared x subtract 1 plus 2 sec squared x plus 10 sec x plus 8 equals 0. Then we multiply out our bracket, so we get 3 sec squared x subtract 3 plus 2 sec squared plus 10 sec x plus 8 equals 0. Then we can collect it all together, so you're going to get 5 sec squared x. Then you're going to get plus 10 sec x. And then you're going to get 8 subtract 3 plus 5. So that's nice, we've got lots of multiples of 5. So we can divide everything by 5, so we get sec squared x plus 2 sec x plus 1 equals 0. So that's a really nice thing to factorise. You got sec x plus 1. And then multiply by sec x plus 1 equals 0. So you could have actually called it sec x plus 1 squared equals 0 either. But then from that you can see that sec x for both brackets will be equal to -1. And that implies, if we take the reciprocal of it, if 1 over cos x is -1, that also just means cos x is equal to -1. Now if we think about our graph of cos x, so it starts up here. So there's only one place in radians where it's going to equal -1, and that's here at pi. So our solution, shock horror, x equals pi. Hope you enjoyed that one. Why don't you have a go at question 5?